Hello students. So today we will study some basic concepts of chemistry. Question part 1. Disclaimer. The images used in our slide deck are for educational purposes only. We respect the intellectual property rights of the original creators and owners of these images. If you are the owner of any of the images used in the deck and have any concerns or issues, please contact us at sathee@itk.ac.in and we shall remove the images. So what are the topics that are we going to cover today? So we are basically practicing questions on some basic concepts of chemistry, and there will be 15 questions for today. So question number one says that the reaction of N2 plus 3H2 gives us 2NH3, which is used for preparation of ammonia. When 450 gram of hydrogen was reacted with nitrogen, 1575 grams of ammonia were produced. What is the percentage yield of the reaction? Options are A 61.8%, B 41.5%, C 30.8%, and D 20.7%. You have 10 seconds to solve this question. Your time starts now. Okay, now let us see how we can solve it. So, what does the question say? So, the question is saying that we are given a reaction, which is basically the synthesis of ammonia. And what have we said that the 450 gram of hydrogen is giving us 1575 gram of ammonia. Now, one question must arise in your mind that why is the hydrogen amount is not mentioned here. So basically, the thing they have considered is that hydrogen is present in the appropriate amount that is required for this 450 gram of your hydrogen. So this should be there in your mind. So this thing should be remembered in your mind. Okay. Now it is being said that this much amount of hydrogen is giving this much amount of ammonia. Now what we have to calculate? We have to calculate the percentage yield of this reaction. So basically percentage yield is meant by, so what do you understand a percentage yield is that? It is basically the amount that, or you can say simply the percentage that is being obtained by dividing your produce that you have got by the theoretical produce that you must have got, right? So it is basically the way to analyze a reaction's efficiency. Now the correct answer is 61.8%. So how to solve it? So first of all, let us see the equation that is given here. So the equation that is given here is already balanced, so we don't need to balance this reaction. Now we will write the say equivalence in terms of masses, and we are taking 1 mole of each, right? Means we are taking this as a molar thing, right? So we are taking 1 mole of nitrogen, 3 moles of hydrogen to produce 2 moles of ammonia. Now 1 mole of nitrogen is reacting with 3 moles of hydrogen. Now 1 mole of hydrogen will be 2 grams. So 3 mole of hydrogen will be 6 grams. Similarly, 1 mole of nitrogen will be 17 grams. Therefore, 2 moles of nitrogen will be 2 multiplied by 17, that is your 34 grams. Next, moving on to what will 450 gram of hydrogen will produce. So first we are calculating the theoretical yield. So 450 gram will produce how much? Very simple. So according to this, 6 gram is producing 34. So 1 gram will produce 34 by 6. And 450 gram will produce 34 by 6 into 450. That will give you 2550 grams. So this much amount of ammonia will be obtained. So it should have been obtained. Okay. So this is the theoretical yield. But actually we are getting 1575 gram. Okay. So what we are getting? We are getting 1575 gram. Now, how do we calculate the percentage yield? Very simple. Percentage yield is given by the yield which you got divided by theoretical yield multiplied by 100. Okay, so you can just imagine it in terms of examination that the exam is of suppose 100 marks, you got 60 or 70. So what is the percentage that you got? So that is the thing. So 2550 was expected. 1575 was that we got multiplied by 100, which gives us 61.8% as your answer. Clear? Moving on to next question. Question number 2. Question number 2 says that A sample of ammonium phosphate whose formula is NH4 whole thrice PO4 contain 3.18 moles of hydrogen atoms. The moles of oxygen atom in the sample is how much? Options are 0.265, option B 0.795, option D 1.06, and option D 3.18. So you have 10 seconds to solve this question. Your time starts now. Okay, so let us solve this question. First of all, what is the question asking? Okay, the question is asking that we have a sample. Okay, the ammonium phosphate sample with formula is NH4 whole thrice PO4. Very simple formula. You can think of it. Ammonia, then ammonium will be NH4 plus and PO4 minus. Okay. Anyways, now it is said that this sample is taken, this compound sample is taken, and in that sample we have 3.18 moles of hydrogen atom. So see, we have hydrogen atom here. So the content of that sample means the hydrogen content of that sample is given. Now, corresponding to that, what will the oxygen atom content present in the sample? So we have to find that. First of all, the correct answer is 1.06. If you look at the explanation, now the explanation is this way. So we are saying that if you take 1 mole of this, okay, so if you take, suppose we are taking 1 molecule, I would not say 1 mole, we have tested 1 molecule of this for ammonium phosphate, then it will have 12 hydrogen atom. Okay, very simple, 4 3s are 12, and 4 hydrogen atom, because oxygen is having a 4 as a coefficient, stoichiometric coefficient, right? So what will be the ratio accordingly of H2O, that H2O, that will be 12 is to 4, that finally reduced to 3 is to 1 as a simple ratio. Now we are being said that we are having 3.18 mole of hydrogen atom. Okay, so hydrogen atom mole is 3.18. So this thing is given, and we have to find this, right? So if you look at this, then you can simply say that 3 mole of hydrogen corresponds to 1 mole of oxygen. Or we can say 1 mole of hydrogen corresponds to 1 by 3 mole of oxygen. Okay. And what we need for 3.18. Therefore, 3.18 mole of hydrogen will correspond to 3.18 by 3 mole of hydrogen. That will give you 1.06 mole of oxygen. Okay. Sorry. So 3.18 by 3 mole of oxygen, that will correspond to 1.06 mole of oxygen. Clear? Very easy to solve. You just use the unitary method here to solve this. Moving on to question number 3. Question number 3 says that 1 mole of potassium chlorate is thermally decomposed and excess of aluminium is burnt in the gaseous product. How many moles of aluminium oxide are formed? Options are A 1, B 2, C 1.5, D 3. You have 10 seconds to solve this question. Your time starts now. Okay, let us try to solve this question. So first of all, what is the question? The question is asking that you are having potassium chlorate, okay, and 1 mole of that potassium chlorate, and this thing is thermally decomposed, means it is heated, and this results in the breakdown of this compound. Now, whatever the gaseous product that is obtained after the decomposition, that is used for the combustion of, or you can say simply reaction of, aluminium with oxygen. Now, how many moles of aluminum oxide will we get? So we are say oxidizing this, or we are combusting this aluminum, so you will obviously get aluminum oxide. So you have to predict that what will be the mole of aluminum oxide if 1 mole of potassium chlorate was used. So the correct answer is A. Now let us see the explanation. So first of all, we write the decomposition equation. So KClO3, 2 moles of KClO3 decomposes to 2 moles of KCl and 3 moles of oxygen molecule. Similarly, whatever oxygen that we get is used for the decomposition of aluminium, combustion of aluminium. Therefore, If you write the balanced equation accordingly, which is corresponding to 3 moles of oxygen, then we will write that 4 mole of aluminum will react with 3 moles of oxygen molecule to give 2 moles of aluminium oxide. Clear? Very clear. So why we have written this equation in this way? Why we use here 3? So that this thing can be corresponded. Now, if we just say compare these two equations, then we can simply say that 2 moles of this is giving 3 moles of oxygen, and this 3 moles is used by aluminum to give 2 moles of aluminum oxide. Now, and by analyzing this equation, we can simply say that 2 moles of KClO3 is producing 2 moles of Al2O3, because this is the oxygen that 2 moles is producing this 3O2, and this 3O2 is only reacting with 4 aluminum. Therefore, 2 moles of KClO3 or 2 moles of potassium chloride is giving us 2 moles of aluminium oxide. Now, how many moles of potassium chloride do we have? We have 1 mole. So 1 mole will correspond to how much? Simply correspond to Al2O3. 1 mole of Al2O3. Because 2 corresponds to 2. So 1 corresponds to 2 by 2. That is 1 mole of Al2O3. So that will be your answer. Moving on to question number 4. Question number 4 says that amount of FeSO4 dot NH4 whole twice SO4 dot 6 H2O whose molar mass is 392 gram per mole must be dissolved and diluted to 250 ml to prepare an aqueous solution of density 1 gram per milliliter, that is 1 ppm Fe2 by weight, is how much? A, options are A, 3.50 into 10 to the power minus 3 gram. Option B, 1.75 into 10 to the power minus 3 gram. Option C, 7.00 into 10 to the power minus 3 gram. And option D, 0.35 into 10 to the power minus 3 gram. So, you have 10 seconds to solve this question. Your time starts now. Okay, now let us see the solution. First of all, what is the question? What is being asked in the question? The question is saying that we are taking, say, some amount of this given salt, which is FeSO4 NH4 whole twice SO4 dot 6H2O, and what we are doing is we are dissolving it in aqueous solution to give 250 ml, such that the volume become 250 ml, and the density of the density of the solution is given as 1 gram per ml. So, two things are given here. First of all, the density is given here. Second thing, your volume is given here. And what have to find? We have to simply find the weight. Very simple, right? Because we know the formula density equal to mass per unit volume. Let us see. First of all, what is the correct option? So, the correct option is B, 1.75 into 10 to the power minus 3 grams, right? Let us see the solution. So, it is being said that this is also written in terms of ppm, right? So this is written in terms of density, and it is also written in terms of ppm. So in terms of ppm, it is being said that 1 ppm Fe2 by weight. Very simple. That is 10 to the power 6 gram of the solution contain, because ppm means 10 to the power 6. So 10 to the power 6 gram of solution contain 1 gram Fe2 plus. Okay. And since the density is 1, therefore 250 ml will contain 250 gram of solution. That will be the possible case to keep the density as 1. Now, what is the amount of Fe2 plus that is present? So how we'll find it? In 250 gram. So we are being said that in 10 to the power 6 gram solution, we have 1 gram Fe2 plus. Okay. So in 250 gram solution, how much Fe2 will be present? So 1 gram solution will contain 1 by 10 to the power 6 Fe2 plus, and 250 gram of solution will contain 1 by 10 to the power 6 into 250 gram of Fe2 plus. Okay, so in this we will calculate the amount of Fe2 plus. Now, how we will calculate the amount of this FeSO4 NH4 whole twice SO4 in 250 gram of solution? So since we have this much amount of Fe2 plus, then if you just look at the solution, salt, we can simply see that. So this thing is coming in which thing? So this is coming in grams. Okay. So as far as we can see that 1 mole of this is containing how much? 1 mole of this is containing 56 gram of your iron. or you can say that 392 gram, because 392 is the molar mass of this salt. Therefore, we can say that 392 gram will contain 56 gram of iron, or we can say that, right? We can say that 1 gram of this, 1 gram of this solution will contain 392 by 56 gram. Okay, but we have to calculate for this much amount, so we are multiplying it with this. So this is the thing that is used to calculate the amount of Fe in 392 gram. Okay, so 56 gram is containing 392, so 1 gram of this solution will contain 392 by 56. And at the same time, we know this, so we have to calculate for this much Fe2 plus, right? So we have to calculate for this much Fe2 plus. So we'll simply multiply this, and that will give you the answer. So the answer is 1.75 into 10 to the power minus 3 gram. Okay, just work it out. It will be easy to solve. Moving on to question number 5. Question number 5 says that excess of carbon dioxide is passed through 50 ml of 0.5 molar calcium hydroxide solution. After completion of the reaction, the solution was evaporated to dryness. The solid calcium carbonate was completely neutralized with 0.1 normal hydrochloric acid. The volume of hydrochloric acid required is atomic mass of calcium is 40. So the options are 300 centimeter cube, to B 200 centimeter cube, and C 500 centimeter cube, at last D 400 centimeter cube. You have 10 seconds to solve this question. Your time starts now. Okay. Now, first of all, let us see the solution. For that, we have to understand the question. So, question is saying that we are passing this CO2 gas upon your calcium hydroxide solution, and we are getting the calcium carbonate. Okay, so this is very obvious. And upon the upon we get this calcium carbonate, we are trying to neutralize this calcium carbonate with the help of 0.1 N hydrochloric solution, whose normality is given. So we have to calculate that what is the volume of this hydrochloric acid that will be required. First, let us see the answer. So the correct answer is option C, 500 centimeter cube. Now, we have to see that what amount of calcium carbonate is produced. We have to calculate first that. For that, we will say that, okay, number of millimoles of calcium hydroxide is 25 millimolar. Very simple to calculate. Molality multiplied by your volume. Okay, so here we will M, capital M. Sorry for that. We will be capital M because we are using to calculate molarity. So capital M should be there, because molarity represented by capital M. Now that will give you 25 millimoles of calcium hydroxide. What is the number of millimoles of CCO3? It is 25 millimolar. It is being said here. Okay, because according to equation, 1 mole of this COOH2 upon reaction with your CO2 will give you 1 mole of CaCO3. Therefore, 25 millimole will give 25 millimole of calcium carbonate. Now, what is the milli equivalence of calcium carbonate? What it will be? So, it will be 25 into 2, that will give you 50. Right? It will give you 50. So, what is the volume of NaCl? So, N1V1 equal to N2V2. Okay, so we have the equivalence. N1 will give you equivalence, which is 50. So, V1 will be equals to divided by N1. So, we'll simply divide this 50 by your volume. Sorry, a normality, that will give you 500 centimeter cube of the HCl. So, this must 0.1 normal solution, which is 500 centimeter cube. This much amount of HCl will be required to completely neutralize the calcium carbonate that is being produced on passing carbon dioxide upon 50 ml of 0.5 molar calcium hydroxide solution. Clear? Moving on to next question. Question number 6. Question number 6 says that sodium nitrate on reduction with Zn in the presence of NaOH solution produces NH3. Mass of sodium nitrate absorbing 1 mole of electron will be, options are A 7.750, B 10.625, C 8.000, D 9.875. So you have 10 seconds to solve this question. Your time starts now. Okay, let us first try to understand the question. So the question is saying that we are taking sodium nitrate and we are reducing it with Zn in the presence of NaOH. Upon this reduction of sodium nitrate, we are getting NH3. So what is the mass of sodium nitrate absorbing 1 mole of electron? So we have to calculate that. First of all, the correct option is 10.6825. What will be the explanation? For that, we have to write the balanced chemical equation. So if we do this thing in basic solution, because we are taking NaOH, then the balanced chemical equation will be formed in this way. So this is the what? This is 2 to the 4 minus 2, that is oxidation of the zinc, and NO3 minus is getting reduced. Okay, so we will give your NH3. So both half reactions are given, and this balanced half reaction, upon addition of this, we will get the required equation, which is this. Okay, so if you just look upon the equation upon adding this, you will find that 8 electrons is being absorbed by 85 grams of NaNO3. Okay, right. So therefore, 1 mole of electron absorbed by this will be 85 by 8. So why are we doing this? So according to this thing, so we know that very clearly. So since 85 grams of NaNO3 means 1 mole of NaNO3. Okay. Now 1 mole of Na. So here, according to this equation, 1 mole of NO3 minus requires 8 electron. So therefore, we can write that 8 gram of electron requires 85 gram. Oh, sorry. 88 mole of electron will be absorbed by 85 gram of NaNO3, or 8 mole of electron is absorbed by 1 mole of NaNO3. Clear? So what will be the mass that will be absorbing 1 mole? So for that, 85 by 8. Okay, so 8 mole is absorbing 85 gram. So 1 mole will absorb 85 by 8. That will give you 10.625. So this gram of your what? This gram of your NaNO3 will absorb 1 mole of electron. Clear? Okay. Moving on to next question. Question number 7. Question number 7 says that 1 mole of N2 and 4 moles of H2 are allowed to react in a vessel, and after reaction H2O is added. Aqueous solution required 1 mole of HCl. Mole fraction of H2 in the gaseous mixture after reaction is, options are 1A 1 by 6, B 5 by 6, C 1 by 3, and D none of this. Now you have 10 seconds to solve this question. Your time starts now. Okay. First of all, we will try to understand the question. So the question is saying that we are doing the synthesis of ammonia because we are reacting N2 and H2, and 1 mole of N2 and 4 moles of H2 are allowed to react. Now, in this reaction, H2O is being added. Upon the reaction completion, H2O is added. And the aqueous solution that we got upon addition of H2O, that requires 1 mole of HCl, okay, for your neutralization. So the mole fraction of H2 in the gaseous mixture is what? Though the correct option is 5 by 6. What is the explanation? So in this equation, balanced equation, we can see that we are taking 1 mole of this and 4 moles of this. But since 1 mole of this N2 requires 3 moles of this, therefore this nitrogen is present in limiting, and that will decide a final product mole. So following this, we can say that upon reaction, 1 mole of this N2, 3 mole of this H2 will be consumed, right? And what we will get? We will get 1 mole of NH3. Okay. And what if you write the balanced chemical equation for the, say, reaction of NH3 with HCl, we can see that 1 mole of this NH3 react with 1 mole of HCl to give 1 mole of NH4Cl. Therefore, 1 mole of NH3 is since produced already. So 1 mole of HCl will be say used up. Clear? Okay. Right? Now we have to calculate what? We have to calculate the H2 mole fraction. So how will we calculate it? So what is the number of NH3 that is formed? So it is 1 mole. N2 that is reacted, that is 0.5 mole is being reacted. Okay. And H2 that is reacted, it is 1.5. Okay. Now N2 that is unreacted, what it will be? It will be 1 minus 0.5. Right? 1 minus 0.5. So why it is saying that? Because we are seeing here that very clearly. Okay, now going back to the question, so I made a mistake here, sorry for that. So going back to the question, it is being said that the ammonia that is produced requires 1 mole of HCl. That means 1 mole of any ammonia is produced. But according to this equation, 2 moles of ammonia would have been produced. Means the total reaction is not occurring. So according to this equation, we have to form, according to this neutralization, we have to form only 1 mole of NH3. So since 1 mole of nitrogen is giving 2 moles of NH3, therefore 0.5 mole of N2 will give 1 mole of NH3. Clear? So we have done it accordingly, because the question is only saying that the ammonia that is produced is requiring only 1 mole of HCl. But according to the proper yield, there should be 2 moles of HCl used. So we do the balancing equal, and that balancing says that we will only say using 0.5 mole of N2 to give 1 mole of NH3. Clear? So NH3 that is produced is 1 mole, and N2 that is reacted 0.5 mole, and H2 that is reacting is 1.5. Very clear, because 1 mole is reacting with 3 mole, therefore half mole will react with 3 by 2 mole, that is 1.5 mole. So what is the N2 that is unreacted? 1 minus 0.5. Okay, 0.5 mole. And what is the H2 that is not reacting? So 1.5 have been consumed. That means 2.5 mole has been left. Okay, clear? Now, since this is NH3 that is formed is being dissolved in H2O, therefore our gaseous phase is now containing only N2 and H2 and not NH3. Hence, the mole fraction can be calculated as 2.5 by 3.0, because in the gaseous phase only N2 and H2 are present, because NH3 is being dissolved in HCl. So total number of moles will be 2.5 plus 0.5, that is 3, and upon above the fraction in the numerator part will be the amount of H2, which is 2.5. That will give you 5 by 6 as the mole fraction of hydrogen. Clear? Moving on to question number 8. Question number 8 says that potassium selenate is isomorphic with potassium sulfate and contains 50% of selenium. Find the atomic weight of selenium. Your options are option A 47.33, option B 71, option C 142, and option D 284. You have 10 seconds to solve this question. Your time starts now. Okay, now let us see the solution. So first of all, let's try to understand this question. So the question says that potassium selenate is isomorphous with sodium sulfate. Means they have the same type, same valency, and all of this are same, right? And contains, so this potassium selenate contains 50% of selenium. So what is the atomic weight of selenium? Okay, so we have to calculate this. So first of all, the answer is option number C. For those who solved is 142. If you got it, well and good. So since it is isomorphic with your K2SO4, therefore the formula of this potassium selenate will be K2SeO4. Okay, similar to that, because SeO4 has a valency of 2 and K has a valency of 1. Clear? Okay. Now the molar weight of K2FeSO4 is how much? So 2 into 39 plus X plus 4 into 16. That will give you, so we have taken the atomic weight of selenium as X. Okay, so we have done that. Now, if we add this, we will get 142 plus X gram of your K2SeO4. So this is the molar weight of K2FeSO4. And we know that 142 plus X gram will contain X gram selenium. How are we saying that? Because we are assuming the atomic weight of selenium is X. So 142 plus X will contain X gram of selenium. Now, 100 gram of K2SiO4 will contain how much? So, 142 plus X is containing X. So, 1 gram of K2FeSO4 will contain X by 142 plus X gram of selenium. Therefore, 100 gram will contain 100 multiplied by this. Okay. But it is written that K2FeSO4 contain 50% of selenium, right? So, it is already being written. Hence, we can equate both of this and get the value of X as 142 gram. So, this is the atomic weight of selenium. Clear? 142 gram. So, same thing written here, that atomic weight of selenium is 142. Moving on to question number 9. Question number 9 says that acidified KMnO4 oxidizes oxalic acid to CO2. What is the volume of 10 to the power minus 4 KMnO4 required to completely oxidize 0.5 of 10 to the power minus 2 molar oxalic acid in acidic medium? Options are option A 125, option B 1250, option C 200, and option D 20. So you have 10 seconds to solve this question. Your time starts now. Okay. Now let us try to understand the question. So the question says that we are taking KMnO4 and that KMnO4 oxidizes CO2. So what is the volume of 10 to the power minus 4 KMnO4 that is completely required to oxidize this much molar oxalic acid in acidic medium? Okay, so we are taking 0.5 liter of 10 to the power minus 2 oxalic acid in acidic medium, and we have to completely oxidize this thing. Okay, CO2. Now, the molarity of this KMnO4 is given 10 to the power minus 4. Now, first of all, the correct option is D, that is 20. So, KMnO4 react with oxalic acid according to this equation in this acidic medium. So, you can see very clearly that 2 moles of this KMnO4 minus is giving us how much? So, it is completely reacting with 5 moles of C2O4 2 minus, which is our oxalic acid. Clear? So, we can write that equivalent weight of KMnO4 is how much? Okay, it will be 7 minus 2, that is 5. Okay, so molecular mass by 5. That will give you 5, the normality as how much? The normality will be equal to 5 into molarity, that is 5 into 10 to the power minus 4. Clear? Okay. So the equivalent weight of each of this will be how much? So for C2O4 2 minus, the molecular mass by 2 into 4 minus 3, this is your equivalent mass of oxalic acid, or we can simply write it as molecular mass by 2. What is the normality of C2O4? What will be the normality of C2O4 2 minus? It will be 2 into molarity, that is 2 into 10 to the power minus 2. Now, according to normality equation, N1V1 equal to N2V2. Hence, we can write this thing and get the volume as 20 liter. So, this is your option number. 20 liter is your correct answer. Moving on to question number 10. So, hemoglobin contains 0.33% of iron by weight. The molecular weight of hemoglobin is approximately 67200. So, the number of iron atom present in one molecule of hemoglobin is, options are A 1, B 6, C 4, D 2. So, you have 10 seconds to solve this question. Your time starts now. Now, it is being said that hemoglobin contains 0.33% of iron by weight. The molecular weight of iron hemoglobin is also given. It is 67200. Okay, so we have to count the number of iron atom that is present in one molecule of hemoglobin. Now the correct answer is C, that is 4. Now according to this percentage part, we can say that 100 gram of hemoglobin contains 0.33 gram of iron. Okay, so 67200 gram of hemoglobin. So we are given 67200. So 67200 will contain how much gram Fe? 0.33 into 67200 by 100. That is how much? 221.76 gram of iron. So this much gram of iron will be present in 67,200 gram of hemoglobin if your iron is 33% weight, is having 33% mass percentage in your hemoglobin. Okay. So what is the number of iron atom? What it will be? So let us see the solution. So this much say hemoglobin, this much hemoglobin contain this much of iron. The number of iron atom will be, so we have to calculate the number of iron atom basically. Yeah, that will be 2 to 1.76 by 56. Hence it will be 3.96. That is 4 will be the correct answer. Question number 11 says that what volume of hydrogen gas at 273 Kelvin and 1 atm pressure will be consumed in obtaining 21.6 gram elemental boron. Atomic mass is 10.8 from the reduction of boron trichloride by hydrogen. Your options are A 89.6, B 67.2, C 44.8 liter, and D 22.4 liter. So you have 10 seconds to solve this question. Your time starts now. Okay, now let us see the solution. So the question says that what volume of hydrogen gas and 1 atm pressure will be required for obtaining 21.6 gram of boron from the reduction of boron trichloride by hydrogen. So the correct option is 67.2 liter. For that, we have to write the balanced chemical equation of the reduction of BCl3, that will give you 3 by 2 H2 reaction will give you B plus 3 HCl. Okay. Now we have to get 21.6 gram of elemental boron. So number of elemental boron is how much? Number of moles of elemental boron will be how much? 21.6 by 10.8 given mass by molar mass. Very simple. So 2 mole of boron atom is to be required. Okay, along with this HCl. So number of moles of H2 consumed will be how much? So it will be 3 by 2 into 2. Okay, how much? 3 by 2 into 2 according to this thing. According to this thing, this much mole of H2 will be consumed. So what will be the volume of H2 here? So it is basically 22.4 into 3. That will give 67.2 liter. Okay. Question number 12. Density of 2.05 solution of acetic acid in water is 1.02 gram per ml. The molality of the same solution is, options are A 1.14 mole per kg, B 3.28 mole per kg, C 2.28 mole per kg, and D 0.44 mole per kg. Okay, so let us see the solution. So the density of this thing is given as 1.022, 02 into gram, that is gram per ml. What have to calculate? We have to calculate the molality. So if you have solved it, the correct option is 2.8. If not, then also no problem. We will solve this question. So what is the molarity of acetic acid? It is 2.05. Okay. And mass of CH3 in 1 liter is how much? 123 gram. Okay, so it is 2.05 into 60. So the mass of one solution is 1 liter solution is how much? 1000 into 1.02. Okay, so this is simply your say your density that is being used. That will give you 1020 grams of solution. This is the mass of solution. So what is the mass of water? So that will be 1020 minus 123, that is 897 grams. And hence molarity will be how much? So it will basically how much? 2.05 by 897 into 10 to the power minus 3. We have converted the centimeter cube to decimeter cube. That is the reason we are converting this, multiplying by 10 to the power minus 3. Okay, very obvious to solve. Moving on to question number 13. Question number 13 says that a 15 ml sample of solution is 0.04 in selenium 2 plus, tin 2 plus and X molar in Fe2 plus. Both are easily oxidized by Cr2O72 minus in acidic medium to SN4 plus and Fe3 plus and itself reduced to Cr3 plus. Now 18.0 ml of 0.125 Cr2O7 is required. Okay, thus X is what? Options are A 0.1410, B 0.205, C 0.820, and D 1.640. Okay, now let us see the solution. So what are we taking here? So we are taking 15 ml sample of solution, and it is 0.04 molar in SN2 plus and X molar in Fe2 plus. Now both are easily oxidized by this CrO4 2 minus in acidic medium, okay, to SN4 plus and Fe3 plus, okay, itself reduced to Cr3 plus. So in this process, your Cr3 plus is reduced to 180 grams of 0.125 of Cr2O7 2 minus required. So we have to calculate X, okay. So correct option is 0.820. So what will be the explanation? First of all, this is your oxidation of SN2 plus, which required 2 units, okay. Now Fe2 plus will require 1 unit electron, and Cr2O7 2 minus to Cr3 plus will require 6 electron unit, 6 units of electron. What is the mini equivalence of SN2 plus? So it will be simply 15.004, okay, 15.004 equal to 1.2. This is the amount of SN2 plus. Now what is the milli equivalent of Fe2 plus? It will be 15x multiplied by 1. Okay, 15x multiplied by 1. What is the milli equivalent of Cr2O7 2 minus? So according to this equation, it is how much? 18.0125 into 6. Clear? So this means that 1.2 plus 15x gives us 13.5. So x is equals to 0.82. Okay, so this is your correct answer. Moving on to next question. Question number 14 says that a mixture of Na2C2O5 and KHC2O4 in 1:1 molar ratio. Now mixture is neutralized by 100 ml of 0.01 molar KOH. What volume of 0.01 molar KMnO4 is used? Then the mixture is oxidized by, so option A 200 ml, B 100 ml, C 90 ml, and D 80 ml. Let us see the solution. So the mixture is containing 1:1, means if there are 8 moles of Na2CO4, then there are also 8 moles of KHC2O4. So that thing is written. Now this mixture is neutralized by 100 ml of 0.01 molar KOH. So what volume of your 0.01 KMnO4? Okay, so what is the volume of 0.01 KMnO4? We have to see. Thus the mixture is oxidized by what? First of all, the correct answer is D, which is 80 milliliter. So according to this, KHC2O4 is equivalent to KOH, and hence we can say 100 ml of 0.01 KOH is equivalent to 100 ml of 0.01 KH2SO4 equals to 1 millimole of KHC2CO4. So multiplied 100 by 0.01, that will give you 0.01 mole of KH2SO4. So this is the amount of Na2C2O4, which is again 1 millimole. Okay. So total C2O4 is how much? 2 millimolar, 4 equivalents. So if V is the volume of this KMnO4, then N1V1 is used. So V into 0.01 into 5, because 0.01 is the molarity, 5 is a factor, and V is your volume, and that should be equals to 4, or V is equals to 80 ml, your answer. Question number 15. Weight of 1 liter milk is 1.032. It contains buffer, fat, density is given 865 kilograms per meter cube to the extent of 4% volume by volume. So the density of fat free skimmed milk will be option A 1038.5 kilogram per meter cube, 1032.2 kilogram per meter cube, 997 kilogram per meter cube, and 1000.5 kilogram per meter cube. Okay, now let us see the solution. First of all, we try to understand this question. So weight, so 1 liter of this milk weighs us 1.032 kgs. Okay, now it contains buffer fat to the extent of 4%. Out of this volume, 4% volume is having this butter fat. So the density of the fat-free skimmed milk will be, so the correct option is A, 1038.5. Now 100 ml will contain 4 meter cube of this fat. Okay, according to this. Okay, according to this, it contains buffer fat to the extent of 4%. Means 100 meter cube of milk will contain 4 meter cube of fat. So weight of butter fat will be 1 meter cube. In 1 meter cube will be 4 by 100 into 865. Okay, so that will give 35 kgs. Why we have done this? Very simple, because 4 by your 100 will try to bring it in line and multiplied by 865. Because your density is given as 865, we multiplied this thing by 865 to get us 35 kg. So what is the weight of 10 to the power 3 centimeter cube of 10 to the power 3 centimeter cube of milk? That will be 1.032 gram. This is the weight. Now what is the weight of 10 to the power 6 milligram? That is 1032. Okay, multiplied by say 10 to the power 3 simply. So weight of skimmed oil is how much? 1032 minus 35. Clear? Which is 997 kilogram. So the volume of skimmed oil will be 1 minus 0.004, that is 0.96, and hence the density will be 997 by 0.96, that is 1038.5. This is your answer, kilogram per meter cube. So thank you. This was all for today's class.